Okay. Alright. I got a cap on because I just woke up and I have a very bad hair do. Yeah. Anyways, welcome to my physics performance task. I'm going to discuss to you hydroelectric power plants, harnessing the power of water. There's literally nothing more to explain in the title. It's literally harnessing the power of water. So anyways, what is hydroelectricity? So hydroelectricity is my simplified form of saying hydroelectric power, so that it's gonna be not hard to pronounce. I don't gotta say hydroelectric power every time I say hydroelectricity. So hydroelectricity is simply electricity generated by harnessing the energy of flowing or falling water. It is one of the oldest and most widely used renewable energy sources. So key facts about this whole thing is the process of hydroelectric power generates 16% of electricity production globally as of recent data. It says 2024, and it's clean, renewable, and reliable. Yeah. Next are the basic principles of hydroelectric power. All right. Let's just call it hydroelectricity from now on because it's really hard to pronounce. Okay, so this is the whole process of hydroelectricity generation. So, water flows from a higher elevation to a lower elevation, then it turns the turbines. And then these turbines possess kinetic energy that gets turned into mechanical energy, and then that said mechanical energy are converted by the generators into electric energy. So, simply put, water flows here, generates kinetic energy, and then a mechanism here turns that said kinetic energy into mechanical energy, and then that mechanical energy is taken in by the generator to create electric energy, and then that's spread all over to your houses and to whatever city you're living in. Okay, that should be enough. That's literally the most simple way of explaining the process: kinetic, mechanical, electric energy. That's it. It's not hard. Next are the examples of dams, the designs of dams. So this one is the Graphite Reef Dam. It's somewhere in the U.S. So this one is called a diversion dam, where a dam is built to divert water from a waterway or stream into a different water course. It's as simple as that. Okay. Next is the Coolidge Dam in Peridot, Arizona. So this one is called a buttress dam. That's the name of the dam. It's buttress dam. Is the name of the design. So this is a dam consisting of watertight parts supported at intervals on the downstream side by a series of buttresses. So a buttress dam is its upstream part is a relatively thin flat slab, usually made of reinforced concrete. It's also a multiple arch dam, essentially. The basic definition of this entire thing is that it's basically a multiple arch dam. So essentially, a buttress dam is composed of a series of arches for the upstream face. I don't know why they had to make it complicated. Alright, last one is it's called an arch dam. So this one is the East Canyon Dam in Morgan, Utah, and it's a concrete or masonry dam which is curved upstream so as to transmit the major part of the water load to the abutments. So essentially, you don't need to listen to all that. It's the basic word or the basic description of this is essentially a double curvature arch dam. So it's curved vertically as well as horizontally. You just can't see the curve because of the angle of the picture. And next, advantages of hydroelectric power. So, this whole thing, see that? This whole thing relies on the water circle, which is continuously replenished. It also has low operating cost. Once built, maintenance costs are relatively low. Clean energy, no direct emissions of greenhouse gases. Oh my god. Reliable and flexible, so it can provide baseload power and respond quickly to demand changes. So you can basically change the output if everybody is living too much in one damn place. Alright, next are the challenges of hydroelectric power. So, The downside to all of this, to all of that things over here that I showed you earlier, is that there is significant disruption of aquatic ecosystems and fish migration once that thing is built. Next is there's also alteration of river flow and sedimentation. There's also high initial costs. Building dams and infrastructure is expensive. Yeah, I can see, doing all of that is pretty expensive, I would reckon. You look at the thing, it probably could house 100 people inside there. Geographical limitations. So it requires specific terrain and water sources. And it could also displace communities due to reservoir creation. So these are some global examples of hydroelectric power plants. So these are some pretty big power plants, I would say. Yeah. This one is the Three Gorges Dam in China. It's somewhere around the Yangtze River. This one is the Itaipu Dam. It's near the border of Brazil and Paraguay. And this one is the Hoover Dam. So this one is pretty iconic. If you watch Transformers, this is where they hid Megatron. Next are innovations and innovations and the future of hydroelectric power. So, if we do all this, right? If we continue to do all this, the key of achieving net zero emissions by 2050 could be achieved by doing all of this. So, if we continue to pursue hydroelectric power, we could reach our net zero emission goal by 2050. And the potential for growth in this industry is that untapped hydropower potentials can be realized in developing countries. Yeah, we actually had a dam in Kalinog. It's called the Halaud. It's the Halaud Dam. Halaur Dam. Yeah, it's like a really big dam in Kalinog. It's made by Daewoo, and it's there in Kalinog, somewhere around the mountains. I wouldn't know because I haven't been there. Next are the challenges to address. So as I've said, I've already talked about that said challenges earlier. So let's just move on to the conclusion of this whole thing. So hydroelectric power is a reliable, renewable, and clean energy source. Despite challenges, it remains a critical component of the global energy mix. So we should all invest in sustainable hydropower projects, support innovations to minimize environmental impact. Yeah, I'd also support lower bills to pay. Yeah, I think pretty sure like hydroelectric power plants offer you a lower bill to pay every month. So yeah, I'd support this over like coal emission power plants. Right. Thanks for watching this educational venture of mine. I hope you learned something.